Hi, I'm Cheryl Sorace-Agaskar from MIT Lincoln Laboratory, and I'm going to be talking about our fabrication and integrated photonics capabilities. For those of you that don't know, MIT Lincoln Laboratory is a federally funded research and development center that works on developing and applying advanced technology for problems of national security and economic competitiveness. And we really conduct R&D activities from long-term technology development to rapid prototyping. And our goal is to work broadly with the national community, government, industry, academia, and not-for-profits to solve difficult problems in the national interest. One of our main facilities in terms of that technology development is our Microelectronics Laboratory. This is a DoD trusted ISO 9000 certified 90 nanometer CMOS line. And we really aim to work kind of to bridge the gap between what you can do in a university clean room, which may be very flexible, but is not necessarily particularly mature or stable, and what's available in industry clean rooms, which is very mature and stable processes, but that might not have the flexibility you need when you're doing sort of earlier stage research and development. And we are the most advanced silicon-based fabrication facility in the country that's dedicated to supporting government needs. So, what do we make in this fabrication facility? We make a number of things, and we're always interested in developing new ones. Some of the key ones are shown here. They include, CCD imagers, cryogenic and radiation hard CMOS circuitry, superconducting electronics, MEMS, and microfluidics, and gallium nitride on silicon, and integrated photonics. And I'm going to focus a little bit on integrated photonics for the rest of the talk. We are a vertically integrated photonics house. We do everything from component and circuit design to control algorithm development, so you can run the thing once you've made it. As I mentioned, we also do fabrication. In addition to our CMOS fabrication, we have a compound semiconductor lab. We do 3.5 fabrication, and we can do some other things as well. And we have a packaging laboratory so that we can bond things up for use in a system, and that includes fiber and wire bonding. And we have a full test lab that has optical testing over a number of wavelengths from the near UV well into the infrared, as well as electrical testing, which depending on the wavelength can get out into the tens of gigahertz. So we've worked with other people to take projects from the drawing board all the way through to a tested module. But we also have worked with many people on just one piece of this, depending on what their particular needs are. We're really here to help the community kind of make progress and to fill in the gaps where people may have needs. I did want to highlight a couple of our integrated photonics platforms that we support and that we're happy to talk to people about getting access to. The two main ones are up here at the top. One of them is a visible light platform that covers from the near UV out into the near IR. And over the last few years, we've developed a large passive component library at many different wavelengths in that range. And we're working on actually just being able to span that range completely. And we also have some more recent work on active devices if you look up some of our papers. The other main platform that we've been working on a lot lately is a silicon nitride platform for 1550 nanometers. This has thermal phase shifters in it. It has 0.1 dB per centimeter loss. And this is a very mature platform that we've been running many times a year for multiple years. In addition to those two platforms, we have a number of sort of add-ons that we've been developing, including pick and place component integration for lasers and photodetectors, and ultra low loss, low confinement silicon nitride, as well as bonded thin film materials, especially lithium niobate. And then separately, we do have a silicon photonics, sort of a standard silicon photonics process that we run. And we often use that as something that we integrate monolithically or combine with other platforms like our silicon nitrides platform or like a MEMS platform. And so if you're interested in any of this, whether it's the platforms or design or testing or fabrication needs, there are a number of different ways to partner with us. I want to start by being very upfront about what we can and cannot do. We are happy to provide R&D work, and we can provide units for R&D and units for the government, but we are not a merchant supplier. We do, however, have the ability to license our IP or technology transfer things to merchant suppliers, should that be a desire. And depending on what you want to do and who you are, there are a variety of different contracting options that are listed out on this slide. And if you are interested, our contact information is on the bottom, and a good first point of contact is to email the MEL director at Lincoln.
So when small business and industry are not able to access component and services, they really should be reaching out to you, right? From the commercial
I think so. We
Yeah.
definitely are interested in talking to people who are have needs that they haven't been able to find.
Could you expand on sort of what you see people coming to you for that's not available in the commercial marketplace right now, at least from an R&D where you help them out?
Yeah, it depends on the person. I mean, I think visible light photonics is something that's just starting to become available, depending on like who you are and what you need. We've had some interest in low loss silicon nitride. We've had a lot of interest in some of our lasers that we develop. We've partnered with people on that, as well as we've had some interest in some non-quantum things like beam steering. So we really do a lot of different things, and it depends on the person and what their needs are.
Great, thank you, Sherry.